So let's make sure, as we're doing these, that we understand what's going on. Try not to just look for a method that you can just follow and that'll solve every single problem, and you don't really have to think about what the problem is at all. You try, in some ways that's good, like with the mixture problems, we found this method, I showed you the boxes, how to fill it out, and that worked on every problem. These, it doesn't quite work that way, because the questions are going to be different. If you take a quick survey of everything, like on the front, this one's asking, like, how long did it take in hours? So we know our variable we're trying to find is time. But if you flip over to the back side, right, starting on number 5, it starts asking find the average speed. So when we did the mixture problems, the R, we're trying to find R, the rate. When we did the mixture problems, it was really the same question repeated over and over, slightly different variations, but more or less it's the same thing. We didn't have to change anything. The questions are entirely different. Much easier to understand them and to figure out the differences and the variations than to be looking for some magic certain way to solve every problem. Now there is a way to make a box and do everything, but just what you do with the information is different depending on the problem. So I'll show you kind of both ways. Okay. But the most basic way, well actually no, there's a few things I have to explain. They're not always automatic for everybody. Sometimes people will not think about this. But I'm going to use this example. Don't write this down. This one is what? We're going to the very opposite box. So let's just say this is home. Very opposite. A few things we have to know. Number one, this length represents a distance. So this is like halfway there. This is like 3/4 way there. This is all the way. Okay. Point number one: the distance from here to here to get there, and the distance to get back. What do you know about these? How are they related?
The same distance.
Same distance. We have to know that because some of these problems they might say the distance from here to here is one thing, and they might say, well, they didn't tell me how much it is to get back. And that's true. It's not automatic. I mean, if you go someplace and then you take a different route to get home, yeah, they are different distances, but we're assuming it's the same exact route. So that much you can assume. The distance there and the distance to get back is the same. So when they don't give you the distance for the return trip, but you can figure out what the distance was on the way there, you can use that for both. All right. Also, just basic. If you go 20 miles per hour for 5 hours, how far have you gone total miles? You go 20 miles an hour for 5 hours. Okay, so 1 hour, you go 20. After 2 hours, you've gone 40, right? After 3 hours, you've gone 60. After 4 hours, you've gone 80. And after 5 hours, you've gone 100. So to find out what the distance is, you multiply the rate and the time, and that gives you the distance. So rate times time is the distance. If you ever want to calculate how long it will take you to get someplace, you can find out how far away it is, how far away is Vegas, how fast, what's the speed limit, or what speed you're going to drive, and you know how long it takes to get there. Just keep in mind in real life, you don't drive exactly 20 miles an hour the whole time, right? Speed up, slow down, that whole thing. So we're just going on a very generic problem that says we go exactly 20 the whole time, no faster, no slower, and just, so it's more of an estimation than anything else. Okay? But these two things we need to know. So if you know how fast you're going, and you know how long you're going that speed, you can figure out how far you get. Okay? And you can see here, you did these problems actually in the 5th or 6th grade. You just did them with very small numbers. It's basically multiplication. It's like your 20s, counted by 20s. It's repeated addition, which is multiplication. So we can, given these two things, we can solve a lot of these problems. The first point is the biggest. First point is the biggest. So let's start over. Start over, and I'm going to map this out the same way I just did, just with this problem here. So, again, the whole length here represents the distance, which is rate times. To get there, taking a round trip, on the way there she traveled 30 kilometers. Now to change this to miles per hour, you multiply it by 1.6. It looks like a small number. It's actually faster than before. Let's see what else. Per hour. So per hour is a fraction. It means 30 kilometers for every 1 hour. We don't usually write them, over 1 hour. We just write per hour. 30 kilometers per hour. But that means every hour is 1 times 30 kilometers. And on the return trip, going slower. Okay. And what else do we know about that? How long? It took 6 hours to get back, right? So over here, we did this for 6 hours. 6 hours. So what is the total distance from here to here? Based upon this information, how far is it? So 20 kilometers per hour for 6 hours. How much? 120 kilometers, yeah. Same thing as before, right? So 20, 40, 60, 80, 100, 120. So we can use that, the fact that it's 120 kilometers on the way back, to help us figure out, like, well, okay, I need to go 120 kilometers, and I'm going 30 kilometers per hour. How many hours would it take? So this whole distance now is 110 kilometers. How far? If we go 30 kilometers, let's just map it out. 30. Okay, we'll come next. 60, and then 90, and then 120. Yeah. How many hours is that? 1, 2, 4 hours. So this is one method of going about solving these problems. Notice how we use the distance on the way home to figure out how long it took to get there, because it's the same distance either going there or coming home. Now, if this is too overwhelming, and we can go back to a plain old table, but the problem is that once you have information in the table, you don't know what to do with it. It's kind of useless. So we can just easily put this information. The blue is like on the way there, so we could put 30 here, right? And put time here, and we could say it's 20 here on the way back, and it's 6 hours. But what else would we do? It doesn't really tell us a whole lot on how to solve the problem. Okay. We don't know the distance. It's very deep. So you have to know that distance equals rate times time. So 30 t equals 20 times 6. So you can solve that, and that's just 6. A little fancy solving here. I'm going to divide by 10 and by 3. Since on this side I see a number that's divisible by 10 and divisible by 3. So divide that by 10 and that one by 3. That's 30, right? Still divided both sides by 30. 10 goes into here 2 times. 3 goes into here 2 times. Here 4. So, yeah, we can use this, but it's very difficult since these problems change from what they're asking. Well, once I fill it in, what do I do with it? how do you know to set it equal to each other? So anytime you have a return problem, I call, okay, a return, or actually we call it a round trip. Call it round trip problem. So you're going someplace and coming back. That's when you just set the two equal to each other. Top row equals the bottom row because the distance, 120, is the same. That's why it's such a. Notice in the equation, we didn't have to figure out 120. We didn't figure that out. So a couple ways of looking at it. Hopefully that helps out a little bit so you see it visually. Let's drop down to 3, try another one. I'll let you guys do sums on your own. So go ahead and draw this across your paper, like that. Label the two locations. So Nicole left the mall. And we're going towards the lake. So write everything out so we have a good visual. If you want, draw a little lake. And Nicole left the mall. This is a round trip. This is her going there, and then, oh no, two people. This is just her going there. So I'll put Nicole up here. Put Adam back there. And this represents the two rows that you have on the box. So on the top, Nicole goes at 24 kilometers per hour. So we put that on top. We're trying to find out how long did Nicole travel. So I don't know how many hours. 3 hours. Find out. Let's see here. We know Adam, let's see here. Adam left 2 hours later, and then he's going 40. So how is this problem the same? How is it different? Oh, time. How long, compared to Nicole, how long is Adam driving for? If he leaves 2 hours later. Driving 2 hours more, 2 hours less. Yeah, he leaves later, so he drives less. So his time is whatever Nicole drove minus 2 hours. If he left 2 hours later. He got off before 2 hours later. But then, you notice how he drove fast and catch up with her. So these should go together. The fact that he left later, so by the time he leaves, if she's going 24 kilometers per hour, by the time he leaves, she's already 48 kilometers out. After 2 hours, that's when he leaves, and he starts going. His first. His first is at 40 kilometers. So really, after only 1 hour, he's almost caught up with her. She's at 48. He's at 40. Yeah, it's pretty fast. And then, so we're trying to figure out how long before Adam caught up. What we can do, we can just keep going on this. So once again, the distance that they're traveling from the mall to the lake is the same. It is the same. So we can use the same thing we did in number 1, saying, well, this distance of 24 times 2 is going to be the same as Adam's distance, which is 40 kilometers, but 2 less hours to drive. So that's why it's that. Can we have a negative answer? No. Yeah, we have the same restrictions as we did before with the mixture problems. You can't have negative liters. You can't have negative time. Yeah. How many hours from now will it take you to get there? Oh, 5 hours ago. -5. That kind of answer doesn't make sense. Okay, so solve that. What did T come out equal? Once we solve, distribute. Once you solve it. Alright. And we got, yeah, what's the answer? 5 hours. 5 hours? You all agree? Okay. Okay, she'll end up going 5 hours. We'll go, this is what, 1 hour, 2 hours. After 3 hours, she's done 72. After 4 hours, done what, 96. And after 5 hours, 120. And then we'll add in here, it's going to go 40. So 80. And then it'll be at 120. So I'll get to 1, 2, 3 hours. Good for 5 hours. Pretty easy. Now, how long did it take Adam to get there? 3 hours. 3 hours, right? So be careful of the question. If we change this to how long did it take Adam to travel before he caught up with Nicole, right? Well, we got 5 hours here, but remember, here's Adam's time. It's 5 minus 2, and that's how we get the 3 hours that we saw right here. 1, 2, 3. So always look at the question. Make sure that's what you answered. Just like before, we don't want to get T equals and say, okay, we're done. Because that's for sure what the question was. All right, so I think that pretty much outlines these problems, these catching up problems and round trip problems, pretty much the same. We can accept the distances are the same, so we accept that equal to each other. Let's take a look at number 5, which it changes to, well, we're going to tell you how long it took. We want you to figure out, well, how fast do they have to go? So, same thing as these problems, but what if they gave us it took 5 hours and it asked you, well, how fast did Adam have to go? And we'd have to come up with 40 kilometers per hour or something. So, same exact formula, same exact setup. It's just the variable is going to change. It's going to be an R instead of a T, and you should be able to solve this in similar fashion. So again, round trip. Round trip. So did it identify, like, okay, I'm going there, coming back, so this is just like, oh, that's just like this problem. It's just like something I've already done. So that way it doesn't feel like a brand new problem. You have to figure out everything out on your own. Just go on. Well, here's what I did before. That works. So keep it up. Okay. So round trip. The trip took 4 hours. 4 hours. Get there. And a trip back took 5 hours. That's a long drive. He averaged 24 miles per hour on the return, so the 24 goes back there. He must be driving his moped. 5 hours at 24 miles an hour, that's a long drive. Long drive. Or he's taking the bus. return. So same idea, but you notice that the variable is now how fast. But compared to what we just did, right, up here, same idea, only they just, and before we're finding the time, and we're given the speed, now we're given the speed and it's find the time, but the setup and the formula is the same exact thing. You multiply the top, it equals the product at the bottom. So at this point we can see, this is pretty much the same as what we've already done. 4 times r, the top distance. Again, we're going on the assumption, took the same route there and back. So the distance here from home to the lake and the distance here from lake to home is exactly the same. That's why these are very important assumption. Alright, solve that, and I recommend you look back. Remember when I divided by 30 times 10? Same thing here. What was that? I see a number over here as divisible by what I want to divide by. So as opposed to just multiplying, let's multiply 24 times 5 and then divide by 4. Divide by 4 without multiplying them together. Save yourself a little work. So 4 goes into 24 6 times. 6 times 5, 30. Of course, if you did 24 times 5 and divided by 4, you get the same answer, but different numbers. What are the units? 30 what? Yeah, kilometers per hour, miles per hour. Never did on this one. Miles per hour. So I'll make that. And this is how fast we went on the way there, on the way back. On the way there, yeah. That's where we put our variable. Our variable is on top, r, and that was on top was on the way there, from home to the lake. So, did we answer that question? What was the average speed on the way there? Yes. Kayla, many trips to Town Hall and back. So the end around trip. Trip there took 4 hours. Trip back took 6 hours. She averaged 24 kilometers faster on the trip there. Okay. So the one we went faster on should be the shorter or the fewer hours of the two. You go faster, you get there sooner. Okay, so say home, down home. Okay. Trip there, 4 hours. Trip back, 6 hours. Going there, and it's coming back. Going back there. And she averaged 24 kilometers faster on the trip there. So even without them telling you, like, this, without reading the second part of this sentence, they will, if they went faster, that would have to go when they got there sooner. When they got there 4 hours, that has to be when they, when they were getting back there. So we know this rate is 24 kilometers faster, kilometers per hour faster than when on the way there. So on the way there we went, 40, and on the way home we went 40, which means on the way there we went 40 plus 24 is 60. Just making those numbers up, but the idea that this is 24 more than this. And we're trying to find what is the average speed on the outbound trip. So outbound, this would be inbound. On the way there, it's called inbound. And then outbound would be leaving. Okay, so we need to know just R. Find out what R equals. Okay. Solve the equation, find R. So once again, the distance from here to here is the same as the distance from here to here. So distance is rate times time. This rate times time equals this rate times time. Solve the equation. Don't forget your distance. And I'll leave you with this last problem. Number 7 and 8 are actually slightly different. If you read the question, you can see that they went in opposite directions. So we normally say, well, we're starting here and we're going to here. But really, we're talking about two different people starting here in the middle at the hospital, right? And then we have Beth is driving, let's say, east, and then we got Cody over here, and he's driving west. So this is slightly different. It's not a return to it. It's not like going someplace and coming back, or they're both going to the same lake, and how long do you think to catch up? So they're driving different speeds, different distances altogether. Fundamentally different questions. Alright, so still plug in information. So Beth traveled 45 miles per hour for 4 hours. And Cody left 2 hours before that. So how long did Cody drive for that? I mean, we know our variables go to speed. We've got no speed in that car. But with this information, how long did Cody drive for? Give it a second. Come on. Any ideas? Six. And why is 6? Exactly. So if you drove 4 hours, and they say he left 2 hours before that, that's 6 hours total. So again, you see how these problems are not necessarily routine. You can't just say, well, they didn't tell me how long Cody went. See, it doesn't say Cody went 6 hours, so you can't do it. You have to put all the information together. In other words, it's the same thing as the mixture problems. The hardest thing about these math problems is the English. And you read the English and know what it means. And you put together, you know, Beth went for 4 hours, Cody went 2 hours before Beth, and figure out that, well, that means 6 hours. And it's not, yeah, it's kind of math, 4 plus 2 is 6, but it's really more, you know, logic. Putting things together, putting pieces together. And what is different about all this? So, we know this whole distance right here. They're 330 miles apart. So no longer is it, oh, these two are equal. They're not saying these are equal, like each side did, what, 100, 150, 165. They're not saying like, well, half of 330 is 165. No, they went at different speeds. But they do know that from here to here, and from here to here, those together add up to 330. So it's kind of different, whereas these add up. This distance right here plus this distance right here equals 330. So 6R plus 45 times 4, which is, that equals, they add up to 330. So this is 180. basically they're asking about, well, how much is this? One- This would have to be about 250, or 150. This would have to be 150. Right? And then if you're going for 6 hours, you drive for 6 hours and you get 150 miles, how fast were you going? Figure that out. 6R plus 180 equals 330, right? So 6R equals 150. So same question. But the 330 miles apart, we know Beth's 180. We take off 180 from 330. So the 150 miles left, we know Cody did that in 6 hours. So 6 times what equals 150. So Cody's rate is 25 miles per hour. At 25 miles per hour, he'll be 150 miles away, and then all together, those will add up to 330. Good stuff. So use the rest of the period, do the evens all the way through. If you want to use these charts, that's fine. If you want to use a table, that's fine. As long as you understand the difference and similarities between all these. So all these are basically the same problem except for 7. All of them we solved using the same method except for 7 and 8. So those were all return trips or going the same direction. Number 7 is when they're actually going opposite directions, and we had to add those up. We didn't set these equal to each other. Because one went 180, one went 150, they weren't equal distances. Only when they're going the same place and then coming back, or just both going the same place, same distance. Alright, so hopefully that helps. Again, we'll pick one of these as your quiz question. So it's good that you wrote everything down, but also make sure you can do these by yourself. Okay? So